Yeah, it looks like the room's starting to fill up, guys, so we might kick things off. Thank you for joining us. It's great to be able to put on another webinar for MEC, and this time in the underground metal space. So exciting for us as a business to be moving into this service offering. So I'd like to introduce Alessandro Dotta. So he is our new underground metals principal. He joins us in our Perth office, and he comes with years and years of experience. So thank you, Alessandro, for putting this together for us today.
Thank you.
So just about a bit of an introduction. So MEC Mining is a mining engineering service provider. We've conventionally been over in the East Coast, based out of Brisbane, but we've since diversified over the last 15 years, and we've now got offices in Brisbane and Perth, and we service the open cut, underground metals and coal markets. So I guess as a business, we put these types of webinars together as one for professional development for our own people, but also to share with the greater industry. So yeah, we're happy to be here today, and we're happy to answer any questions you might have. So on that, if you do have any questions, there is a Q&A button at the bottom of the screen. You can enter questions during the presentation, and we're happy to answer those as we go. If there's anything which is maybe outside of the scope, we can wait till the end and ask the question then, and hopefully you've got about 20 minutes of Q&A time at the back end of the presentation. So as we look at the recent geological exploration results across the world, large-scale, high-grade deposits are becoming increasingly scarce. This has forced exploration companies to pivot from defining outcropping surface structures to searching for deposits at depth. The capital intensity and complex geological conditions forces an increased focus on the mining methodology, selection, and ongoing operational performance of the asset. So celebrating MEC Mining's recent expansion to underground hard rock mining services, we're very pleased to present this webinar on effective application of sub-level open stope mining. So Alessandro will be discussing the geological and geotechnical selection criteria for sub-level open stope mining and variations which may arise from concept plan to reality. In addition to this, he'll outline the associated productivity expectations for the mining method and some of the technical challenges which exist during the execution planning process. So yeah, we really hope you take away some key information out of this webinar today. And as I said, our goal is to help you guys successfully move your asset lower on the cost curve and from a concept into reality. So ask any questions you have, and we'll try our best to answer them. So as far as the format goes, Alessandro will be talking for about 30 minutes in presentation. We are happy to answer questions as we go. So yeah, as I put them in the Q&A box, and we'll get to those. You guys should all be muted, so I'll be reading the questions out to Alessandro on your behalf. So if there is any other additional context, just please feel free to put it into the chat box as well, or add it to the Q&A. A little bit about Alessandro. So as I mentioned, Alessandro is our principal mining engineer for underground metals. So he's got about 15 years of experience in the industry. His expertise provides support to our clients for underground metals operations and projects to help problem solve as they adapt in the challenging landscape. He has an arsenal of qualifications and plenty of experience, having worked on underground metals operations widely in Australia and overseas, and most recently as the principal mining engineer with GEMS Australia, where he delivered strong results in a wide array of challenging situations. He's highly skilled and armed with a raft of experience across commodities, mining methods, and software. His expertise is in cross-functional team integrations and optimum safety compliance, and they solidify his effectiveness as an engineer. Alessandro's work ethic and practice strongly reflect the way we work at MEC, and his experience and problem-solving approach mean that he will complement our already diverse and strong team. And Alessandro, welcome, and I'll hand it over to you to commence the presentation.
Okay, so thanks, Andrew. Thanks for the introduction. So first of all, I'd like to welcome all the participants and for taking the time to attend to this presentation. So I'll try to focus on some of the technical aspects of the mining method and hopefully deliver more hands-on information that can help you to decide really about the methods, and also some theory as well. So, okay. Let's start our presentation. So as Andrew mentioned before, if you have any questions, please send them through and we'll answer as they pop up. So, all right. So first, I'm introduce you guys with some general pictures. You can easily find this sort of pictures on the internet, but it's more to understand what the mining method is about. So this is of course a bulk mining method. It's not like you know, a selective method like narrow vein stoping or anything like that. So it means that you need to consider like a dilution and some other factors if you intend to apply sub-level open stope. So we'll be discussing a little bit about you know, the ore bodies, what are your requirements. So just on those two pictures here, a couple of things for us to take a look is more understanding, you know, the general picture, what you would expect from this method. So you can see straight away they use of raised bores to create like a first void to be able to blast your slot. So we'll be discussing that. Also the use of cable bolts, you know, to hold your walls, that can be very common, depending again on your ore body strength. Also here you can see, you know, you can have couple of different drilling patterns as well. So this one is a fan drilling from central drive. You can have also some you know, half drilling from parallel drives as well. So this is more like a introduction you know, picture for us. So let's go dig a little bit more deep into the method. So let's talk a little bit about the ore body itself. So we expect when applying sub-level open stope to have a stable and competent rock on both hang wall and the footwall side of your ore body. So we're talking mainly about medium to high strength. So the strength on that case, we're talking about something like, I don't know, if possible, higher than 70 MPAs. Also low to medium stress regime. So that will collaborate, you know, when you open your stopes and don't have like, you know, big issues with dilution and also unexpected falling of rocks or even collapsing. Also, we about like the deposit, like the angle, would like to be on the, you know, ideal range above 60 degrees, and that again that plays more on the inclination and it exceeds your repulse angle. So then you don't get on a situation where you have your ore partially hanging on your footwall and having issues recovering. Because then, you know, you could incur in not just dilution, but also don't have the expected recovery. So let's talk a little bit now about the ore body. Define a little bit like a little bit more what do we mean about like the large size of the ore body. So as mentioned, first is a bulk method. So we expect to have a large ore body with a regular shape and well-defined boundaries as much as possible. So we're defining here X and Y dimensions, but when we talk about those dimensions, what would be really, what are the numbers involved? So I'd say that on the X axis, we're talking about in the order of 100 to kilometer in length. That can vary. You can have like a multiple ore bodies. It depends on continuity as well. So when we talk about the Y position, we're talking about like tens to hundreds of meters. And again, that depends on a couple of factors, but I would say I'll address that those should be the main dimensions to understand. The depth of the ore body, that's variable, because that depends at the end of the day on some geotech constraints and on your rock quality. So because that will affect your pillars stability and primary and secondary stope size as well. So that can be said that's variable. So now talking a little bit about the stope size. So for this mining method, largest as possible for high efficiency of the method. And the reason for that is because as you see on the next couple of slides, that will influence mainly on the regime of like a bogging sometimes, and also on your blasting effectiveness and other factors. But we can talk a little bit about like the grade. So this mining method you can do with medium and relatively low grade. You should expect dilutions, again, depending on your stopes, on the paste fill, fallings, or even boundaries. You have like some waste and some internal structures. Also, let me see what else in here. Yeah, as you go deep with this mining method, I think we need to mention as well that your stope size, they tend to decrease, and that's just a factor of your stability. So I'll put here like a basic view. This is just more for us to understand a little bit how the method applies. Look, you find out there a lot of variance for this method. Okay, this is in no means represent like the method at itself. In the box you have a lot of variance, so you could have some different pictures or different applications, but this one I think represents very well what we want to discuss today. So initially, we are showing here some transverse stopes. Usually, you will expect to have a slow start. So your initially blast on the slots, you're talking about like 1,000 tons or something on that order of magnitude. And as you progress, you have like a bigger blast. So as sequence goes, the method itself is more likely to be applied as a bottom up, but when you see in reality sometimes you'll be required to do some chains, but that's not common, but sometimes you need to. So then very quickly here, so blast the bottom, blast the top. Of course here is implied there have a slot, so we see that on the next slides. And then you keep progressing your method. So here's something important to notice is the way that you're retreating on the method. So, and the reason for that is mainly for stability and also protection of your bogger position. So your open brow position, if you're retreating the panel towards from where you'll be assessing with your bogger, you have a better protection. Of course, this is not always possible, but if you can, this is a plus. Also here, just notice that about the size, this void here, the main reason for the slow start is because of void, okay? So we'll be discussing that a little bit further, so then you can have a mass blast and you have like enough void for that blast.
So sorry, here, Alessandro, just going back to that. So
yes.
you've got the 3 levels in this picture.
Yes.
What would stop you from going to 2 levels in this case?
What would stop me from?
From going to 2 levels and increasing your height of your block?
Look, you can increase the high. There is a couple of factors in here, and I would say could be some geotechnical constraints from you. To have like a bigger stope than really what's presented on the picture with some multiple levels. That also another factor you need to consider will be about the drilling. So as we go further on our presentation, we see that you have like a limit. It's not the ideal limit, but I'll put as this way, you don't have like too much interference with a deviation from holes. But if, let's say, if you want to increase distance between levels in here, you could consider like a regime of drilling up and down holes. So you could eliminate the middle level and drill like up holes from the bottom and down holes from the top. But again, you need to watch out about like interactions when you're going to through your timing and blasting. Okay, all right. I hope the answer is okay. So go to the next slide. On this one, we present a little bit like the magnitude and the size actually of those slots. So this is a real stope that has been mined. So as previously discussed, we can see here the size from where you have your rise. Here on this case, we have a one with a raise bore and they slot, so each one of the blasts. So blast 1, 2, 3, and 4 on this case. So these guys, they are contained at the bottom here. So number 1, and I just have the picture actually what's contained inside of the slot. So you see as order of magnitude, we're talking about like 1,000 tons, 1,500 tons at most in here. When you go through the next blast, that'll be 5 and 6, you go to an order of magnitude between 18 to 20 times bigger. So again, I would like to reinforce that the reason for that is because you don't have enough void. So you need to create your void, you need to be very careful while you create your void. And we'll be discussing about the importance of your slots and how careful you need to be while doing that. So you don't want to jeopardize the extraction of your whole stope. You can have like a couple of millions involved in revenue in here. So it's better if you go slow and respect some of those constraints than try to go way too quick and jeopardize what's inside of your stope and incurring in time loss and loss of revenue as well. So fire 7 and 8 in here, they probably could be taking a single shot because we have enough void at the bottom, so we'll be okay. And then even like 9 and 10, it could be taken as a single shot as well. Again, look at the order of magnitude. So we went from 1,000 to 20 times more. And then the final blast, the number 11, as the mass blast, we're talking about 115,000 tons in a single blast. So that's very representative when you're talking about bogging, mainly free bogging. You can have a very high production if you have multiple stopes online. Okay, so the next slide, I'll just comment a little bit about a couple of upsides and downsides of the method. Look, on the paper, of course, everything seems to be like very nice, but sometimes you have a couple of things that are undesirable. Let's talk first about the upsides. So as I mentioned previously, so we're talking about like a free bogging ranging from 40 to 70% of the stope. That's depending on size and blasting directions. It depends on pile formation, how you form that at the back of the stope, or if you push material to the front of the stope. So the stope tonnage, as on the previous picture, we saw it can reach easily above 100,000 tons. And of course, that means, a relative low cost per blast. That again, it depends on a couple of other factors in here. What would be the maximum tonnage? So we'll talk about like a little bit outstanding ground competence and stability. So that will allow you to have entirely stope drill before blasting. And that's the ideal situation when you want to maximize your drilling stocks and also the blasting readiness. Of course, there are a couple of factors in here that could comment. That depends on material when talking about your broken stocks. And that goes back to if you have like a high sulfides material, you can incur in what people call the industry cooking. So your material can solidify again. You have difficulties removing that from your stope. But again, you need to think about what about the coordination of the material that you have on the ground, about the grades, how you move them to the stockpiles on the surface, how you treat them on the plant. So look, at the end of the day, you require a very decent communication between your departments with geology and mining. So we'll talk about like productivity. So it's very high productivity per blast. So yep, I will talk about like our broken stocks and depending on ore type. So on the downsides, we could mention here the paste fill planning, the commissioning operation that requires a well-trained personnel. Look, and that goes mainly when on the initial steps, because you have like some binder adjustments understanding what the strength that you want to achieve. So again, this is important to comment. So the paste fill process is usually a costly process as well. It doesn't really matter what sort of mining method. You always need to consider how much money you'll be spending on that, mainly on binder, and then also the initial implementation of your paste fill plant. So it requires relatively precise drilling and well-trained operators, in this case for both, for drill and charging. So mistakes, they can be like very expensive, and that goes mainly on slots, but we'll comment a little bit further on this matter. So high capital costs on initial stages. And the main reason for that is because this mining method usually is most applied from like a bottom-up sequence. So meaning that you need to develop all your levels before you start that. Eventually, it works better if you have multiple ore bodies. That is way easier to work and more flexible, but it doesn't move the idea of a high capital cost on the start. And also a selective method, it's not very selective. This is something a little bit tricky, mainly because constraints on your stope shape that can play a big factor sometimes.
Just before you move on, Alessandro,
yes.
I noticed there's a difference between your central production drive and your parallel production drives. What's the difference in the widths?
Okay, look, this goes back again as you're drilling. So if you have your parallel drives, you can increase your drilling distance, because now you're drilling like from both sides, and that'll be easier. We'll have like some tables that's going forward, and they reflect this this sort of change on distance. So if you have parallel drives, you have like a couple of things that can prove for you. Drilling parallel to your boundaries, that will help to keep your either paste fill neighbor strength, because you're not actually stabbing your production holes and making holes either on your paste fill or on your in situ pillars. But the main reason here talking about like the increase in distance is because you can drill from both sides. So then you can almost double up the size, but not to that extent. It depends a little bit on the angle of your drill hole, but that's the main reason for that. So yeah, okay, going to the next one. Let's talk a little bit about dilution. So dilution can be really a big factor on this mining method application. So I'd like to talk about like to focus on two main things here: the planned and unplanned dilution. So of course, when we'll talk about like planned, we'll talk about like internal dilution. And internal dilution we could see as internal waste. The stope shape, also the stope shape has some limitations and bring this internal dilution. So look, when you're applying this mining method, it's not all the time that we are applying for a massive ore bodies. Sometimes we're talking about mining multiple structures that carry grade, but between those structures you can also carry waste. And that's the reason why internal dilution can be a big factor, and you need to pay a lot of attention when talking about this method. So the second one, talk a little bit about the halo of mineralization. So seen here in the picture, mainly outside of the ore body. So the halo of mineralization, in some instance, it can actually helps with your dilution, so decreasing your dilution because you bring some extra ore. But in some instance, you can have some issues with contamination. It's not all the time. Sometimes those boundaries, they can carry some sort of a of mineral that is a contaminant, and that can actually will not be like good during the treating on the plants. So also you can talk about like the paste fill on the stope boundaries. So when you have like a paste fill, again, you can have like some dilution, mainly after like you're blasting or when you expose those walls. And that will depend a little bit on the competence of your dream blast experts, or let's say your engineers on site when they are blasting your stope, and try to be careful to don't damage the paste fill, but it can play a big factor. So we can talk also about like a backs over breaks and also the walls over breaks. And this is again is on the assumption side. So you look, when you're going through your project, sometimes a couple of structures, they are not like a really well mapped, or they are like a micro structures inside of your stope, and you can have some overbreak. So always the assumption side, they'll bring like some numbers that they will be usually better than when you go to the unplanned case. So let's take a quick look on the unplanned case, and then we get back to discuss this one. So on the unplanned side, we'll talk a little bit here about the overbreak, so above assumptions. So look, at the levels of overbreak, they can be above your project initial assumptions, and the reason for that is because they can be led by bias or poor geotechnical data, and sometimes you don't fully understand how your ore body is inserted in some of those microstructures that sometimes they are not identified during your drilling. Mainly, if they are like a parallel to your holes, you could have issues in identifying them. So that could be one of the factors. Also talking about structural, and it's exactly that. Some of those families of joints, sometimes they're not like very clear on the initial models. So I think it goes a little bit through a process of from the start of your operation and your geotechnical department, really understanding where we're stepping in with some underground drilling that will help it also to define a little bit better what you really what's your ore body really can be represented. Also talk a little bit about like a paste fill. So that again, and it goes above the assumptions when you try to understand the strength of your paste. So as you work through your binder mixture, you see that there will be a lot of room for improvements, mainly dealing with your paste fill strength. So, and that can cause unplanned dilution as well, something that you not expect and go above your project assumptions. And something that I'll leave in here for us to think about is a little bit about like stability. So, and the competent ground, the concept versus reality. So it's always good to reflect about it. What's the project and concepts, and actually how it is on reality. So here, just like a last picture, just to mention, sometimes you can have some displacement at the backs that they're so huge, they can land on top of your ore pile, and really you can lose the whole ore that's inside of the stope, because you have no means to reach this big rock and do a secondary drill and blast. So yeah, it can be very expensive. So let's talk a little bit now about like some of the cycle times. Look, this is more like a general data really here. So let's talk a little bit about like drilling. So it's slot meters. We'll talk about like 1,000 to 2,000 meters. And you would expect on the slots to be is lower than normal, and that's mainly due to a couple of factors here. So you have like a very frequent change on diameter of your holes, and that's like considering your reamers, they will be larger templates than what you have on your production holes. Also, another thing to understand here is that you constantly moving your machine, and also you change like drill bit size. If you're talking about downhole, you change your drill bit size to do your collars and fit your pipes as well. So on the collars. On the stope, so we could say that we'll talk about 180 meters average day drilling. It can be more, can be less. Look, it's just like a very like a rough estimate. So on the stope production rings, that is quicker. Mainly because you drill like it's fan drilling, either down or up holes. Usually up holes, or not usually, actually up holes will be quicker, because again, like cleaning the holes is way quicker. Gravity will help, to clean the hole. Down holes, you have issues like, cleaning, and also again, you need to collar with a different diameter usually to feed your pipe. Let's go a little bit through the preparation. So preparation is usually quicker on upholes than downholes, and that's again, upholes don't get like really blocked. Downholes can get like blocked for a lot of reasons. So I'll put here average prep downholes about like half shift per level, half to 1 shifts per level. When you for upholes, sorry. When you're talking about downholes, 1 to 2 shifts per level. Talk about the prepping. So when you go through charging and blasting, look, sometimes I like to talk more about like emotion charging, and I would recommend to use emotion because unfollow can be an option, but you have some issues in here. You require experienced charging crew. It's difficult to work with upholes. When I say experienced charging crew, it's because you can have water issues. You need to sleeve your holes. There's a couple of things play in there. When you work with upholes, it can be tricky to keep your info inside of your hole. So with emotion, it's way easier as far as your guessing parameters are done properly and you have an experienced charger. And again, I'll keep mentioning that water is a massive issue, mainly when talking about like a downholes. Also, remember the fact that when you talking about downholes, you take like a lot of time blocking your holes as well, and a couple of other actions that you need to take before charging. So the charge rates, look, I'm talking again about emotion. I would say probably about like 6 tons per shift. So a truck average would be something between 4.5 and 4 tons. So you can do probably one and a half truck depending on conditions and the charging. Production holes will be quicker because you'd be like charging on your fan holes. The use of detonators, I would recommend to use just electronic. You can use milliseconds, but again, milliseconds probably you would consider just for small blasts that are on these lots. But timing, look, it can be very tricky, and the slot is the most sensitive part of your whole blasting. So I think it doesn't worth the risk to use a milliseconds instead of a electronic detonator. So with precision issues, logging time depending again on number of people and skills. Bogging, so can talk about like 2,200 tons per shift on the free bogging, and probably about like 1,600 tons per shift. Be careful on logging as well. Who does the logging? If it's your engineers, be careful. Or you can turn your mining engineer into a civil engineer, and have a new bridge inside of your stope. So let's go through here a little bit of a talk. Discussing actually the concept and reality. That's going through more the implementation. So look, I'll talk about drilling. It'd be important to understand the standby times for production holes before you affect charging and blasting. And I put this information here because at the mine side, during like the daily base, you always interest to increase your drill stocks. That's very important. So then you have a lot of mobility when you are going to the next phase of production. So we'd also like consider here a little bit like the internal faults and sympathetic detonation when you have like voids or even like faults and deviations. Now make some comments here. So this standby time, it depends on a couple of things. So downholes, you can have like some blockades that goes through. It can happen with a lot of vibration and moving, some structures inside of your hole. You can also have personnel and machining working in the area that so unless you block those holes, there's lots of ways to do it with sponges and sand. There is lots of ways, but again, you can have issues if you leave also your holes open for a long time. It depends on the stress on the ground. You can have like some cracks that build into the formation of your holes. In the case of internal faults and structures, you can incur in some deviation. So look, what you plan, again, and this is exactly the concept versus reality. So sometimes you're expecting to extract way more than tons from your stope, but if you have deviation and you have like a poor extraction of a corner, you can end up to have some solid lump in there that your bogger can no longer access, and you lose part of your ore inside of your stope. So, and again, that's the reason for like, watch out for concept versus reality. And this stuff here, they clear those questions as you go through the operation and understand a little bit better those concepts. So voids, they can affect mainly on sympathetic detonation. And sometimes you don't really even realize those voids are in there unless you have a very experienced prepping crew that can identify that, when you're blowing your air hose through, or even identify, some of those gaps in.
Yep. So sorry, just before you move on, we've got a couple of questions that have come through. So what's the main cause for deviation? Is it fault structures? Is it changes in medium? Is it pull down pressures? What's causing the deviations?
Look, I would say, I'm not like really, I'm not geotech, but what I would say on my experience, the main cause for deviation, I'll point to. So one is actually, it's a little bit of the structures. If you're drilling in an angle that's is a shallow angle, with that structure, so almost parallel, you incur some deviation. And another one I would say is the experience of the driller and how careful he is. Sometimes you can increase your pressure on your rods, on your drill bit, to be able to drill quicker, but the operator needs to have the proper feeling and understand when he can do that. Otherwise, you can have some banana holes, and that can happen very often. You have some banana holes, and you need to call for moving your rings and re-drill again. And that can happen sometimes. So it's something for people on operational level to watch out.
Yeah, for sure. And so what would make you choose a downhole over an uphole?
Look, I would say, if you're talking about like a production rings, I would say upholes, they are like probably the best way to go when it's possible. But again, it depends on how you're going to retreat your levels. Upholes, they are not possible. Mainly on that picture that I showed first, on the first slides, you'll not be able to do upholes unless on your bottom level. So what I would say is that as a preference goes, upholes, they are easier to prep and in some instance to charge if you have experienced people to do it. Steaming is not something, and it comes easy. Probably you need to use some special socks, steam socks or something like this. As downholes, what I would say, the best side of downholes is just because it's easier to access, but then you incur a couple of problems, mainly with water. Before you charge and during your prepping, you need to block those holes properly on the breakthroughs. So yeah, and also downholes, they are more prone to deviation as well due to the rod weight. So yeah.
Yep, no worries. And I just have one more around production rates.
Yeah.
So what aspects are the key influences to production rate?
So I would say, like for production, for the race itself, you have a lot of things that we can discuss. There is one slide going forward that will discuss that a little bit more in depth. But what I could mention is that you need to be very careful while you're drilling. That is the main aspect to look at. It's never enough to emphasize that careful and precision drilling is paramount on your slots. I would also mention that timing, your firing, this is another factor that you need to consider, because if you have freeze partially your slots, to reslot your stope can be very difficult, mainly when you consider how your drives and how you position your slot drives. Sometimes you need to develop design a new drive to be able to reslot, and also some consequences as drilling on previous blasted ground, so that can be an issue. Another one that I would mention as well is the use of a raise bore slot rise versus use like a long hole rise. So that's another one. And probably I'll let this one to discuss when you get to the slides. So otherwise, I'll just give it away, all the information too easy. So,
No
but
worries,
anyway,
I'll let you
I'll
carry
clear
on.
that one a little bit further. All right, so let's go to the next one. And this one is talking a little bit like, I'm not going to dig too deep into the mine sequence, concept versus reality, because look, at the end of the day, there are a lot of different ways to do the same thing, and you come out with the right result. But what I put in here is, is the most common, and what people usually will be like the first ideal situation. So when we talk about the conceptual and ideal sequencing, we're talking more about like a bottom up. And the reason for to going bottom up is because you want, mostly to avoid undercutting paste fill stopes. Because this method, we are aiming for like a full recovery of the ore body, because you consider dilution and all the factors. So you want to recover everything. You don't want to leave any pillars unless they are, like a crown pillar that cannot really be removed, or any regional pillars or pillars to isolate stress between our bodies. So unless you have this sort of situation, we'll talk about like you want to mine everything. So you want to avoid undercut stopes. I'm not saying that you can't, you can, but you would expect further dilution. So the initial production usually is relatively low until you have several independent stopes active. So in this case here, you can see that. So stope number 1, then paste fill, stope number 2, paste fill, number 3, paste fill. Then you can have 4 and 4, 2 stopes. And then you can sort of repeat the sequence, 6, 6. Can you see? You double up the sequence. If you have like multiple ore bodies, you can repeat this sort of sequence and have multiple stopes online. Okay. Another reason for this ideal sequencing is the continuous advanced sequence starting on this sort of profile. You avoid extreme stress, and this is an important thing to be discussed. Look, on this book methods is always I would advise to have a very close contact liaison with your geotechnical department and geology, mainly geotech, because you need to really understand the stress distribution. Otherwise, you can end up with a massive stope collapsing and losing a big part of your reserves, and that can play a big role into shorten your life of mine in a couple of years. So it's a couple of examples, but it's like it doesn't worth mention names, but probably professionals out there know a couple of cases where this sort of situation happened. So the paste fill usually follows the sequence. And then the curing times, look, this is a very like a rough estimate, 15 days, but that stuff can change a lot. Now let's look, this is a conceptual, okay? Let's talk a little bit about like the reality. So on the reality, the blocks, they can change like sequence due to a lot of factors, but I just mentioned a couple of them here. Paste delays, stop drilling, some other interactions that you cannot really predict until you are, going through your daily base production. So you have also, so as I mentioned, interaction between levels and jobs that can force your sequence to change. So then if your paste fills something, I stope in here, even if you try, oh, why I cannot take this stope? Well, sometimes, you have your paste fill barriers. You don't want actually to have, a possible disaster on your mind, in paste fill in rush and killing somebody. So you have isolation on your level. So sometimes you could be forced to change your sequence, just because things like this. Also, we need to mention like ventilation constraints. So they can affect a lot your sequencing, just because how you play with your DBR boards or things like this, and secondary ventilation, you can have a lot of effects and changing your sequence. Even if you don't have enough air on your bottom levels, you have some constraints as well. Paste fill curing times, and this one again, it plays more on when you start your operation. You have one idea about what will be your curing times, but as you go through and your personnel and your technical teams gets further developed on their skills, these numbers can vary and change. And also the binder chains, because that, you know, as you are adapting, you can change your binder to a more strength or less strength, you know, less cost. That depends a couple of things. Also, another one that I need to mention is market conditions and commodities price. Look, sometimes we make a plan for 5-10 years, and you know that the grades that you're dealing, they could change drastically in a couple of years time, just because you know, the market is not so favorable anymore, and you know, the price the selling price just went down. Okay, so going to the next one. So I'm going through a couple of technical challenges. Look, I'll just go a little bit quicker because I thought we will reach 40 minutes, a lot of stuff to talk about. But anyway, let's keep going through this one. So the Stope average, we're talking about like really about like a 12 tons per meter. This number again is look, it can be different. It can be very different, but this is average between production holes and also slots. When we talk about production, we have like about like 16 tons per meter of drilling. You can have this number even going way higher than that if you consider just your production rings. You can go up to 20 or even over that. The slot, as you can see, the drill density is way higher. We're talking about like 1 ton per meter of a drill hole. And again, look, the reason for this one is because it's a void. Void is the problem here, but we'll talk about that one. Powder factor, again, for production, as you can see, 0.2 kilograms of explosive per ton of rock blasted. When I talk about a slot, 1.25 kilograms. Again, look, on these slots, the intention is more to create a void. So then, you know, you want actually to pulverize in some instance your rock, okay, and you know, and use also the timing on your favor. So you drop all that stuff and keep open your void when you're comfortable with your void. And then you talk more about like fragmentation. So now you can, you know, reduce a little bit how much explosive weight you need per ton of rock blasted. So a couple of comments in here about some factors about like up holes and down holes, and that's the reason why I didn't comment everything back in there. But look, we're talking about like a quick drilling. So and that's you know, that's just understandable as the cleaning, and you know, it's way easier to clean your holes. Better deviation control, improved drilling speed. So that's again, it goes, the deviation, it goes a little bit about like the gravity and how that affects your rods, because you need to consider that, you know, you're hammering your whole string of rods as well. When they're facing down, it's you know, you have gravity plus you know, you're hammering your string columns, that like more prone to deviation. So up holes also quick preparation. For a lot of reasons that I said previously. You know, cleaning your holes is quicker. Breakthroughs are not that common. Usually they're blind holes, and a couple of issues. You know, yeah, they'll be way quicker. But you have some downsides. So especially steaming, then you need to use like socks. Sometimes people use bags and you know, with some other materials trying to block your holes as the steaming. Emotion, you need to control the gassing. It should be sort of precise, otherwise you can have slumping. Then you have your material coming down with, you know, sometimes dragging your primers as well. So it's not a really you know, a really nice experience to see that happen on your stope just before you're going to blast. And also, you know, consider like experienced charge crew. That plays a big role on up holes. On down holes, easy priming, charging. Look, for priming is very easy. You know, you just put your primer, stuck that down the hole, and keep charging. With up holes, you know, you need to have that with your spider or, you know, your cone, and push it up on the hole and expect that to don't move. But sometimes it doesn't happen this way. You know, it's a little bit trickier to priming. Easy steaming as well. You can use aggregates, sands, or whatever. And then on the downside, longer preparation before charging. Mainly we'll talk about, you know, blocking those holes or get rid of block. Sometimes, you know, you need to have some re-drills and you know, a loss of time. And then again, reinforce that water down holes. They are prone to have like water, and depends again on your mine, and you know, how well drained is your mine, and you know, how much water inflow you have. You need to have, you know, the increased hole deviation that I mentioned before. So the drilling patterns, you can have, basically like in this mining method, fan drilling up, fan drilling down, or you can have a combination of both, in some case. Here I have like a picture, this is like a fake one, and this is like a real situation, operational from mine side.
Just a question coming from the audience there, Alessandro. So what do you do if you've had several adjacent holes close up or block during charging?
Look, yeah, that's a very tricky one. So the first action that probably you will do is try to unblock them by the normal means. And normal means, I mean, your prep crew using the air hose and try to unblock them. If the rock is a small, probably you'll be successful. You can sort of blow them either down or out of the hole. The second action probably will re-drill those, specifically holes, but that can be tricky in some sense if you have a part of your stope is charged. So you kind of like bring machines less than 10 meters in some sites, and that distance can change from charge holes and drill. But also you need to consider the time that you're mobilizing your machine to get to the place, to the drilling site and doing that job. So yeah, you have like a whole delay. And on the last case, really, we'll talk about like a re-drilling through a full hole. If you see, and that can happen quite often, you have some internal structures moving, even like a re-drilling, that wouldn't really help. So you need to consider moving your holes to another position and remap your slot if there's a lot. And that is the nasty situation. Remap your slot before you really charge and blast. So yeah, I'll give this advice probably. Mm-hmm. Okay, let's go to the next one. So here, a little bit about like technical challenge. Look, now we're getting like to the past next few slides, and we're 46 minutes. I'll try to be a little bit quicker on those ones, but anyway, I think it's very important to discuss as well where the numbers come from. Like sometimes we get like a true mine site and we use all these standards that are already in there, but we don't really understand where a couple of those rules, sort of like your burden, toe spacing, where they come from. So look, this one here, you find very easy to find. I use a source here that I don't know, but I just found something that they mentioned that, but you can find on some reports as well. So if, I'm considering here like a drill bit diameter of 8-9 mil. So for your burden distance, we're talking about like something about 25 times your bit diameter. Again, you can stretch that to up to 40 times, but you need to consider what sort of situation. I think it's better you play on the safe side at the start, and then as as you go through and increase your technical skills, you can try to play with this number. So toe spacing 1.5 times your burden. So as an example here, a 9 mil hole, so we ended up with a 2.2 meter for your burden, give or take, and toe spacing about 3.3. Here, I forgot to comment at the start of the slide. So we'll talk here a little bit some problems and technical challenges, mainly about deviation, poor fragmentation and freezing, things that can happen, and then they will very likely happen until you get experience with that. So the maximum length, I put it here like this table, around on this table, you can see on our case, consider 8-9 mil TDS 76 tube. So you can see that for a vertical hole, give or take 24.7 meters. So that goes, for up holes, and we'll talk about up holes in here. We go to up to 25 meters, and then down holes 22 meters. And again, mentioning the difference between ups and downs is mainly gravity. And you can have like more deviation when you're talking about it. When you see TDS 76 for 8-9 mil, 22.2, you have like some some difference, mainly because of deviation. But you guys can always use some table like this. You can find them in a couple of places on the internet. And when you have a hole that's pure horizontal, you need to be very careful. And that again is not just about deviation, but it's about extraction. Blasting horizontal holes, they can be very tricky, and how much material they can really effectively blast and remove. You can then end up with lumps on your walls or floors. So let's go to the next one. Let's talk
just
a
while
little
you're going, Alessandro.
Yes.
We are getting close to the original time. I think we'll see this out and ask a few questions at the end if everyone's happy to stay on. If you can't stay on, this session is being recorded, so you won't miss out. We'll be sending out a link in about a week's time with the presentation. So if you do miss the last sort of 10-15 minutes, you can just watch the webinar link that comes out in a week's time. So back over to you, Alessandro.
Yeah, that's fine. So I'll keep going a little bit with this one. So look, we have there is a lot of information to present. So I'm sorry for the extra time, but I think like people that have this extra time to watch the remaining of the slides, it's very interesting information there. Look, talking a little bit about of your dream blast here with those problems, deviation, fragmentation, freezing. As you go forward, and you develop some acceptable level of confidence of your team, dealing with drilling, charging, time, and fragmentation, I think that will be fine for you to turn it, turning in a little bit more and play with some of your burning distance and tow spacing. Some like you do like small chains at the start and see what happen. With your fragmentation, and you don't get on freezing on things like this until you get really set up of a value that it will result in save of money. All right, but always remember to be very careful and analyze your results as well, about like your fragmentation, and ensure you're not like changing too quick, because you can go from a perfect slot to a frozen slot. Okay, so let's go to the next one. So let's talk a little bit about our slots now, and well, saving that one for later. We had a question earlier, but let's talk about this one. So look, really, slots to me, they are the decisive, they are the paramount step for a successful stope extraction. And so my recommendation is really take your time. Okay, a lot of things can go wrong with your slots, so you need to be very careful. First of all, I would like to recommend the use of raise bores, as I said before, because then you have your initial void. We start with like usually 1 meter diameter a void in here. What's way better than really you try to extract a long hole slot. So look, there is a couple of things to go with raise bores. Sometimes they're not suitable for certain slot conditions, and on the case of the operation is very confident with long hole rise, that's fine, to go with long hole. But what I can tell is that the rate of successful slot extractions and time saving with reslotting and corrections, if you have like a freezing or things like this, redrilling, it will save you a lot of money. And what I would also recommend is that if you decide to go with raise bores, really think about raise bore campaigns, playing ahead of your requirements, so that will save a lot of money. It's a very costly a very expensive part of your raise bores is your mobilization and demobilization. So if you have a campaign pre-planned, you go very well with that. All right, and also that would be good for your shadow engineers to don't get any interactions with other jobs. Sort of I'm putting my raise bore here, but I am, geology wants to do some drilling. So talking about like a long hole rise, I would say, look, be careful with them. Multiple lifts, they require precision when drilling and also mapping then. So your prepping crew, and they need to be very precise, understanding and mapping those guys, because look, it very often happen. You have a pattern on that you're drilling. Let's say, as your down holes, up holes, they usually don't break through. But talking about down holes, and when they break through on the bottom level, and you check the holes, they become a mess, right? And then to be able, to work on your timing, you need to have a proper mapping. You need to understand how those holes interact with each other. So be careful with those guys. They can be applied, but yeah, be careful. Also, the last one, yeah, avoid play with your slot configuration. Look, this is some of the patterns that I used in the past, and the reason for that is because you know, really, if it's working, try to don't break it, and because you know it's not very cost effective saving. You know, it's too much risk and low reward. So here I have like those tables. They are similar as the previous slide. You know, they just show your slot blast hole drilling and also your long hole raise drilling. I'm not like going through that because I think it's, you know, it's, you guys can go through that later if you want, and just trying to understand the numbers that are in here.
Alessandro,
Yes.
we've just got a question from Robert Goose, and it's about the hole diameter. What are you looking at when you select your hole diameter?
Look, when you consider your hole diameter, I would say that the main factors is they'll play as a your precision drilling, also your stope size. I'll probably mention those two factors. Look, if as you increase your hole diameter, you have more bang, a little bit more power blasting that, but also you need to understand the damage that you can cause to your walls, adjacent stopes, and your paste. So you need to be careful and you know, understanding what the impacts. Bigger holes, you'll be able to have a bigger burden distance, so you can push more material forward, and also you have like less holes, you know, with a bigger toe spacing. So look, you have all those factors to think about. Also, bigger holes, it will allow you to have like a bigger distance between levels, because you know you can drill a little bit further with less deviation. So look, I'll consider all those factors really, but I would say, you know, it's a little bit of a mix between all of them, you know, to understand where you want to go to. But I would say that probably this analysis that starts mainly with your distance between levels, you know, that impact on your stope size, you know, that will be defined by your geotech, you know, when you're doing your initial projects. So, okay, so I'm going through here. Look, this one's very quick. Look, so far I just discussed more about like you know, drill and blast, and a little bit of some structural you know, structure, the internal structures of your body, and that's because I consider that to be you know, one of the most important factors to be considered on this mining method. But you know, you have sort of like other things to be considered. And in this case, we'll talk a little bit about like level extraction plans, and you know, what's the importance of them. So look, it's always good you have like a documentation, you know, well documented, how you plan, you know, ahead your stopes and level extractions, because you can compare, you know, later down the track the results that you got with, you know, the conceptual, you know, so the conceptual versus reality. So, you know, some basic data in there: stope location, size, tons and grades. That's like a very basic. Then talk about like a geological description and level of confidence. So that's is really handy, you know, understanding the ore type, you know, when you have like multiple ore types and contaminants, so you understand a little bit how you play with that and with your stope shape, and also, you know, you have opinion of your geologist on you know, on what you're extracting. Now, also, it helps you to understand some of the internal structures that can play a big role on your stope extraction. The level of confidence is very valuable information for, you know, down the track when you do your reconciliation and understand your results. You know, the grades. You know, sometimes you can have like a really big fights on mine sites on a daily basis about the grades of what you plan and what came down the track. You know, engineers and geologists, sometimes they have like some issues with that.
Just on that, Alessandro,
yes.
Is there any software available for your stope optimization?
It does, yes. There is a lot of them. Look, yeah, the most common that I know in the market that I've been using for years and years is MSO. So MSO is the best one for stope optimization. It's the best tool that I use. Look, I really used that for a couple of times, and a couple of those versions that are coming out lately, they are even better because you can play with other factors. So yeah, look, it's a play with that. It can give you really nice results. And whoever asked the question, if you need a hand playing with MSO, you let me know. So okay, so I'll just keep going with this one. So now, also geotechnical aspects, look, they can be like very important as well. Mainly detailing your ground support and stability, stopes and development dimensions and profiles. It's always good to have that registered, because if something changes halfway through, all right, your extraction, it's easy to track and understand if something went like very well, you end up in a really good result, or you end up in a disaster. And also that serves as a formal documentation, in case of you have you require that. So another one here, we'll talk a little bit about existing infrastructure and ventilation, paste fill, sumps and declines. And that's, I think, is very obvious. You understand what you have in place and how much money and cost and time you require until you really establish the next step, that is your mine designs on your levels and infrastructure improvements. So you need to understand very well what you have, so then you can plan what you need to do. And to be able to plan what you need to do, you need to understand very well your mine design parameters, because otherwise you can ended up not being applying standards for your designs and level designs, and then you can have a fight with your geotechs. So look, that's the reason why it's good to have, like, this is the basic data that I put in here, but some place you have more data, really, more different aspects of your level extraction plans. Escapeways and refuge chambers is very, very important. This one probably one of the most important, just to understand your egress way, both egress way, how to get in, how to get out, and then also in case of any incident, you have to prove that all the safe measures has been taken according to the mine regulations, and you don't get in trouble. Also, it's always good, and this one here, a lot of places sometimes don't do that, but I consider that's very important, cash flow estimate. So I'll put one here. It's very basic, but understanding how much money you spending through the process. What was how much really worth your stope, and how much you ended up with a cash on your hand in the end. That's very important. Any questions so far here? Can keep going? All right.
I think keep going, Alessandro. We'll just get the questions at the end.
Okay, beautiful. So let's talk a little bit about like the paste fill. So this one, try to go a little bit quicker because I'm not a geotech, but anyway, I'll sort of try to present, what I know. So we have like some paste fill challenge, and I'll mention here a couple of them. Mainly, deal with high volumes of paste. Okay, in this case here, we can see we're dealing with like 61,000 cubes. Okay, look, you can have really like a paste fill plant, then it can go from 1,000 cubes to a couple of thousand cubes, 3 or so, somewhere on that range. So you can imagine how long time it takes. And sometimes you can realize if you did a mistake on your project, because that would take a long time to the paste fill of your stope. Pipes blockage. So this one is a classic one for everybody out there that work in the mine site, where you have like a paste fill. So look, if flushing is not done correctly and at the right times, you end up with like a sediments inside of your pipes, and they solidify, and then you have like a pipe blockage, and that's very painful. Metal pipes, you need to remove those pipes and find your way to really remove the material inside. I mean, it's a lot of things you need to do, but at the end of the day, it means putting down all your pipes that usually will be attached to the backs of your drive, and then cleaning them, physically cleaning it takes a lot of time to do. Also consider your paste fill holes as well. They can be very challenging, mainly when we'll talk about tight filling. That's another topic here. So the position to drill those holes is not always the best position, because you need to consider where your paste fill pipes are. So sometimes you need to extend your reticulation for your paste filling. So this is very challenging in some operations. Also, the scheduling and then talking about your plugs and walls. So when talking about like you put your plug in here, how long time it really takes to be effective, a plug that I can lift some bands and keeping going with my paste fill, and I can resume my operations on the level where I have my bands lifted up. Yeah, so also walls as well is always good to understand how long time your crew takes to to put them up, and how that will affect your paste fill starting. So it's always good to consider that. On the side here, just put like a little table. Of course, I just intentionally remove some of the names there because it's from a real operation. And look, I have some dates in here, how long time it took, but you can see it can take like quite a decent time. This one, 94 days, pretty much like 3 months for really big stopes. Look, this sort of number usually improve as operation goes, okay? So this number, you get like a way smaller than that, but as they start, usually you get like some numbers, that can seems to be very high. And that's it. That's the end of the presentation. That was the last slide. So I hope that everybody likes the presentation. Look, it's a lot of information to be delivered. I try my best. But anyway, I'm open to questions now.
Yeah, I think you did a great job, mate. Yeah, we'll go through some of the questions we got here. Again, if you guys need to leave, by all means, feel free to. Otherwise, yeah, there's the link coming out in about a week's time with the recording of this webinar, so you'll see all the answers. If you need to shoot off, yeah, feel free. So I've got a question here. I'm not 100% on the context, but what percentage of dilution would you expect, and what sort of reduction in grade would that result in? Feel free to clarify that question in the chat.
I think like a percentage of dilution is something that we can talk. Grades, it depends on what's on the grade, but look, I think like they are related anyway. But I think dilution on big stopes, you can talk something around 10%, also somewhere on that area, even some near 8 or somewhere in there for primary stopes. When you talk about secondary, this number will go up just because now your boundaries, you have your neighbors are paste fill stopes, so you would expect to have more paste fill falling inside. Also, you need to consider stopes that are on the boundary of your body. The dilution can have a big effect on that. Again, this terms of dilution, I'm just kicking that to the extreme. Okay, when you have like let's say multiple loads that you are using a stope shape to remove multiple loads and sort of taking the dilution that's between those loads as a I would have this dilution anyways, a planned dilution. But when you talk about like a massive ore bodies, you can have a very low dilution. If you talk like let's say a massive copper ore body, the dilution would be like a very low, just because you don't have like those multiple structures. The continuity of the ore bodies is really good. So yeah, you have a lot of factors, but I would say to the extreme, you could like think about those numbers, those ranges.
Yep, awesome. Thanks for that. Do you see much of a difference in the theoretical versus the actual curing process?
Yes, look, it can be. I'll say that's mainly at the start of the project. Look, when you start a project, all the data that you have, they'll be mainly from surface drilling and and all those assessment that you had on the theoretical side of your project. Then you'll be planning what sort of binder you'll be using and all of that, mixing with the tailings of your plant. But as you progress, with your operation, and you have the commissioning of your paste fill plant, and you start to have like a real results. And what I mean by that is that you get all this material that is now to be your paste fill, and you're doing all those stress compression tests, triaxial tests, and all those tests that are out there. I mean, geotech probably can clear that a little bit better. But the thing is, as you start to understand a little bit better, you understand if you are playing way too much on the very, very safe side, as people like to say, better be safe than sorry, or if you are not putting enough binder that can cause like some a catastrophic failure on your paste fill stopes, or one of the pillars. So I think that this time, the curing time, it can dramatically change through your operation. As more experience your technical team gets, and also operations goals, that time can decrease significantly. So.
How critical are the placement of the drives in relation to the ore body? Is there any flexibility to increase block size to include halo mineralization after they've been established?
Look, I'd say that drives positioning, they are very important to some extent, and that goes back to mainly when you're talking about drilling. I think as drilling goes, if your drives are not like well positioned, you would end up having a lot of interactions between levels. Also, all sort of interactions between drillings, mixing between ups and down holes. As if you plan ahead how your drives will be positioned, you can define very early, how a whole level will be designed, either as ups or down holes. And that's the reason why I mentioned here extraction plans, and on that matter, they're very important, because you early define how you be mining your stopes. Look, it's very different from have a PFS, and where you have all your numbers and everything on a piece of paper. And of course, those numbers, they have a they write in some instance, they carry with them some let's say percentage of variance to more or less. But I think it's on a daily basis, through the implementation actually, and doing the real mining job, you find out that you need to have some plan done ahead, and that's where I would reinforce the use of extraction plans, because then you don't incur into designing levels and just for the sake of get ahead of development meters, and have your targets of whatever 600-700 meters per month, and you just spend a lot of money with drives. It'll be very tricky to drill. So.
So, is it possible to change from a long hole stope to a sub-level open stope in an active mine?
Yes, I believe that in some instance it would be possible. What I would recommend is, first you need to have a really good geotechnical assessment before you try to do something like this, and also understand if your ore body, the capacities. I mean, if everything is in there, the high strength, all the qualities that you need to apply the method. But I think it's possible. And again, we get back a little bit to the last question with the drives that levels that you design already. Sometimes they wouldn't fit in a profile for a sub-level open stope extraction. But look, a part of that doesn't look a very flexible mining method. Believe me, you can be very tricky and make it happen.
Right. This one's a bit more technical around your paste. So how many MPAs would you typically need to reach with your paste fill mass before exposing neighboring stopes?
Look, that's a very tricky question. Yeah, look, I don't have a number from top of my mind. I'm really sorry. But look, I can try to chase this number and I reply. Whoever is asked that question, if you send me your email, I can find that out for you. But look, I don't have a number on top of my head. I'm really sorry about that one. So that can be, it's a tricky question. Probably geotech will get the answer straight away.
There we go. We got an answer in the chat there from 0.5 to 1 MPa.
Yeah, okay.
I've got a question. So longitudinal and transverse mining, which one produces more dilution?
I would say that probably, look, this is a tricky one. I would say like a longitudinal, I think if you talk about like the area that you're exposing really of your host rock, probably bigger. Because when you go transverse, you're exposing mainly the back end of the stope, the front, and if it's your first stope on the top near your crown pillar, the backs of the stope. So look, I never really got into any sort of analysis, because like the main application that I done is for transverse and not the longitudinal. But I would say my guess is that a longitudinal probably will bring some more dilution. Apart that, it seems to me the longitudinal probably you'll be able to be a little bit more selective if you're talking about parallel drives, right? So you have like parallel drives drilling, you'll be able to drill more parallel to whatever situation you in angles you have of your hang wall and foot wall, as if you have a situation where you have like a central drive and drilling from the central drive, you increase dilution because you just be stabbing your hang wall and foot wall, so that will increase. But my guess would be look, I would say probably longitudinal. I could be wrong on that one, but look, yeah.
What's the first thing you look for when trying to increase productivity on a sub-level stoping mine?
Okay, so first thing that I would say is I would go with understanding more your drill and blast and how you can make your procedures working in favor of you, trying to eliminate levels. So if you can eliminate levels, look, when you start the whole planning process, you think about like how you go in theory, but when you get more practical, you understand that you can sometimes eliminate middle level. You don't really need to have that level in there. And when you talk about like development, consider like a 5-6 gram per meter of development. That's plays a massive cost. So I would think first trying to remove levels if possible. Also, I would play a little bit on the safe side of my drill and blast parameters, and after you start your mine and you have a well-established crew, and you have a proven technique is working already. Okay, you don't have like too many freezings and issues extracting your stopes. I'll try to play with those numbers a little bit, increasing like burning distance, things like this, playing with your toe spacing, a couple of those things. I think also how you blast, in sort of directions that you blast, you can increase your free bogging as well. That's another factor to consider as well. As more you can extend your free bogging is always better. As more you can keep your brow choked, you don't have crack the brow, as people say on the mine side, and you need to move to remotes very soon. As further you can have that, it's it will be a good approach, I would say, to increase production.
How do you determine when to use paste fill plan or go with CRF or waste fill?
Look, I think this one can be like a tricky question. Look, it's not uncommon over there, that you can use a mix between them. If you have a stope that one of the sides of your stope, you don't think that you're going to expose that side, you can try to dump some material, some waste inside of that stope. As far the other drives, you have like a solid feeling. So you'll be able to do like a sort of dump some waste rock in one of the walls that you don't really want to expose, okay? Because if you expose that, you can have dilution or even like some nasty surprise. So you can use probably both methods. If you have a stope that in no way you're going to expose, and I'll be very happy to just lose rock filling that stope. Just be careful to, future crews don't come in and undercut that stope, or you have like a massive issue on your hands. And talking about CRF, I think CRF is a little bit tricky because CRF can be slow. Mainly, you need to create like a mixing bay. Usually you need to consider, you bringing like your trucks, to dump some cement, and you have the bogger mixing that, and dumping that on the stope. I consider to be a slow process. A part of it seems to be, you save a little bit money when you're talking about the initial cost establishing your paste fill plant.
Yep. What are some key factors to consider when stoping remnant pillars?
Oh, look, on stope remnant pillars, I'd say you need to consider mainly the stress distribution. Usually the remnant pillars, they will be necessary pillars, unless, we're talking about a crown pillar, isolating your underground development from actually on underground extraction stopes from, your previous open pit or something like this. So sometimes if there is a lot of money involved, you can try to apply some techniques and understand that, but need to be very careful with like water in rush. And also doing that out of like a raining season. You don't want to expose your mine to this sort of level of risks. End up like floating your mine and losing all your bottom levels. Talking about stress, I think you need to be very careful when you're playing with stopes, if they are related to like regional pillars or things like this. Need to be very careful, because usually those pillars, they are there actually to help to distribute like tensions and all this stress, and have that a little bit more even distributed through your ore body. So I think I would say that. And also at the last, consider if you are going to extract, consider your sequencing, just to overstress your ore body and end up with some really bad consequence from that.
Can you help clients in determining SMUs for open pit using MSO/SSO tools?
Ooh, don't know this one. Probably I need to think a little bit more to answer this question. It's a tricky one, but I need to think a little bit about that one. So, but please, if whoever asked this question, if you could send like an email a little bit more detail about what's what about the job, so then I can take a look and understand where we sit. But I'd say probably yes.
Right. I have one more here. I'm just not 100% on the question itself. So I think it's related to support. So how can you reduce your dilution using support, and how does it affect the mining operation cycle?
Yeah. Look, that's a very tricky one. So the thing is, for your stope, so when you have like a central drive, so just go back to one of the slides here. If people are still seeing these slides, that'll be good to comment. So on this case here, if you have like a central drive, okay, the only way really that you can support here using some sort of support would be like cables through the backs to some extent, and actually you help on the sense that you don't have like displacement, you don't have like rocks actually ended up on this sort of situation here. You have like some falling of massive boulders, rocks on top of your pile, and then that prevent you to recover the ore that's at the back. That can be like very expensive. Sometimes this ore that's in here is what will be paying for, will be your profit, and you just lost your profit at the back of the stope. But when you have like a parallel drives, that it will be like a case more like this, you can actually cable the walls. And actually, I would advise to cable the walls, because that means you can have like a even bigger slopes on that sense. So you can actually cable your walls and prevent further dilution. Because all these structures that that you would have here, like let me see, like these ones, okay. As more cable you can have on the walls, you in some instance you actually you're preventing this those rocks and dilution to end up inside of your stope, and even yeah. So this is a yeah, that's my point of view on the cables and how you can play with that.
Mm-hmm. And I think we might make this the last question.
Yeah.
So plenty of mines have stopes that are intersected by ventilation shafts in their ore reserves. Can you comment on the practicality of that?
Look, I would say that if you have a ventilation shaft, first of all, I think when you plan on a ventilation shaft, first of all, you need to check like very well about sterilization, and that's not just for ventilation shafts. I think that goes for all main infrastructures on your mine. You need to be very careful to don't put like declines, ventilation shafts, or any long-term structures that are required for your mine a proper work in the future inside of ore. By saying that, I think if you want to mine that stope, you need to consider first how this shaft, how that actually plays with your ventilation, how it would really affect. Is there any other means for you, to put a shaft somewhere else that links, and actually make the job that this shaft is doing? Also, you need to include the cost, okay, of putting this, moving this shaft from another place. So that's very important. Otherwise, it seems to be like a really good deal, but you ended up like, have a very expensive shaft to relocate. Also, I would consider probably, if you try to move your ventilation on the sense that, is there any way that I can reverse my ventilation? I mean, if it's not, a shaft that, let's say, is not very important shaft, and just feeds an area with fresh air, or even it's an air return or something like this, how you can play with that. All right. Now, look, if I understood like the question in the right sense, to talk about like ventilation shaft and not like a shaft with a skip.
No, I think you answered it quite well, mate.
Yeah.
Yeah, I think we'll call it there, guys. Thanks for sticking around. Sorry for going over time there, but I think it was worth it. The questions are great, and I appreciate all of that. And it's good to see everyone making Alessandro sweat a little bit. So.
Oh yeah. A lot of questions, but I think it was a really good discussion, and we open room for even like a further discussions anyway. If like people have like all the webinar attendants, if you have like more questions about that I can help, please send your questions. Even if I cannot help, then I'll try to find, sometimes it can be a very complex question. I'll find like somebody can really answer that, and I'll ensure that I'll reply.
Yeah, for sure. And Alessandro's contact details are here on the screen now. So, yeah, any questions, feel free to shoot through to Alessandro, otherwise myself. And yeah, as I said before, that we will be sending out a recording for this webinar, and feel free to pass it on to whoever you want. Yeah, thanks for everyone attending, and thanks, Alessandro, for all the effort you've put in for this presentation.
Thank you very much. Thank you very much. All right. Cheers. See you. Bye-bye.
Thanks, guys.